back to my math YouTube channel. In this video, we want to start talking about how to solve right triangles, and especially you can think of these as application problems of using the trig functions, trig ratios to solve right triangles. Okay, so guys, I have an example number 1 here where we have a triangle DEF, and in this right triangle we already know the length of the hypotenuse here and one of the sides. Guys, we have to find the missing two of the other missing angles. We already know this is 90 degrees, and we also have to find one of the missing sides. So guys, in order to do that, we're going to use a combination of a few different ways, and one of the things that we're definitely going to use is the trig functions or the trig ratios. Now let us start with first let us pick which angle we want to figure out, or if you want to figure out the side right away, you can do that as well, but I'm going to follow what I have in my notes here. Guys, I started by actually evaluating, I thought of trying to evaluate the measure of angle D, and let us see what we need or how we can figure that out. So guys, to find the measure of angle D, now I have more than few options. We know there are 6 trig functions, but guys, the 3 of them are the basic ones, and even with those 3 sine, cosine and tangent, 2 of them are even like the most basic ones, sine and the cosine. So I would highly encourage starting with sine or cosine, and if those 2 do not work, or they do not help us to figure out the missing angle or missing side, whatever the case may be, then we should go into the third one, which is the tangent. So guys, most of the times you'll be able to just use any of those 3 or combination of those 3 to figure out the missing sides or missing angles for a given right angle triangle. You may not have to go into the cosecant and secant and cotangent, which are just the other 3 trig functions. So here, let us say if I have to figure out the value for the angle D, then let us start by writing the very first trig ratio that we know, which is the sine. So sine of D, well, we know the sine is the opposite over the hypotenuse. So if I look at this angle D, and if I think of this as a reference angle, because we are interested in finding the sine of D, then I have to consider D as my reference angle. Then the opposite to that is going to be this D, right? So it's just this side D divided by the hypotenuse. Guys, we can clearly see that the hypotenuse is going to be this 23. So now if I look at this equation, then we can obviously see that there is 2 things that are missing, the angle D and the side D. And there's no way using one equation we can figure out 2 missing things. So what does that mean? That means that we cannot use the sine function to figure out any of the missing pieces here. So we cannot use that sine function. Now if sine does not work, then let us move on to the other one, which is the cosine. Let us set up the cosine function. Guys, cosine of D, we know cosine is the, let me actually write the general form, the rule, and then we'll fill in the values. So sine was opposite over hypotenuse, cosine is adjacent over hypotenuse. Guys, please always, you can write this, or if you remember, so, ka, toa. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is finally opposite over adjacent. That is like a quick and easy way of remembering these ratios. So now let us see what we can do with the cosine function. So cosine of D, we don't know the value for D. Do we know the adjacent? Guys, the adjacent right here is 13, and the hypotenuse is what, 23. So we know both the opposite and the hypotenuse. So from this we can figure out the value for D. Guys, to figure out the value for D, what we have to do, we cannot just directly figure it out just by looking at this equation. We have to use our calculator. So in your calculator, what we have to do is, we have to figure out the D, we have to use the inverse key. So we got to press the cosine inverse, and it is already, there's an inbuilt inverse key. You guys have to first enter the shift and then the cosine, and that will display the cosine inverse, the inverse key, and then you have to type in the ratio 13 over 23. Guys, when we do that, we get 55. So let's go up to 2 places. So I have 55.58 degrees. Guys, one has to use that inverse key in the calculator to figure out this angle. That's how we are going to find out this angle, right? So sine, we started with sine, but sine did not help us, because sine, we needed to know what is the value for the opposite, and in this triangle we don't know yet the value for the opposite. So that's why it does not help us. So we move on to the second one, which is the cosine function, and in the cosine case we had both the values for the adjacent and hypotenuse, and from using the inverse key, we were able to figure out the missing angle, angle D. Guys, I have the value for angle D. So if measure of angle D is 55.58, then I already have the measure of angle E. So to find the measure of angle F, I don't really need to use any trig ratios. Guys, you can use other trig ratio, or you can set up the cosine or sine, and then from there you can figure out the value for angle, measure of angle F. Or the easier way is to realize the fact that, hey, angle D plus angle F, they are complementary angles. They're going to add up to 90 degrees. Or you also know the fact that sum of these three angles is 180 degrees. So to find one of the missing angles, you do 180 minus the sum of the other two. So it's up to you how you want to do it. Let me check my notes. So in my notes, this is how I did it. Guys, I realized the fact that measure of angle F plus measure of angle D is 90 degrees. Because this is 90 and this is 90, so that makes the total sum of the angles of this right triangle to be 180 degrees. So to find the measure of angle F, you just have to do 90 minus the measure of angle D, and we already have the measure of angle D, which is 55.58. So it is going to be equivalent to, I already have the math here, it is 34.42. So I'm just going to write it, 34.42 degrees. So guys, we have the measure of angle F, we have the measure of angle. So I got the value for this and this, and now we have to figure out the value for the missing side D. Now guys, there are a few different ways of finding the value for that D. I'm going to show you both ways here, and then it's up to you which way you want to use. So one of the ways is, guys, to figure out the value for D, and there's probably more than one way. So guys, what I did here was, I set up the ratio tangent of D, and there's a reason why I use the tangent, because I know tangent is opposite over adjacent, right? We already know that. And opposite here is to this angle, the opposite is D, and the adjacent is 13. Guys, I could have used any other value as well. I could have used the sine, because sine is opposite over hypotenuse and opposite is D over. I could have actually used this equation right here, because now I already know the value for D. Guys, I could have used the sine, or I can also use the tangent. So there's many different ways of finding the missing values for angles or sides, using any of the trig ratios. So please be flexible with this. There's not only one way, okay? Anyway, I'm going to show you two ways here. Guys, this is one of the ways. Of course, you could have used, or we could have used the sine. Now from here, let us go back and substitute the values. Tan D is 55.58, and that is equal to D over 13. Keep in mind, our goal is to solve for D. So what we're going to do is, there's an invisible one here, we're going to cross multiply. Whenever we have like two type of ratios equal to each other, one of the best ways of solving for any of the missing variables is to just cross multiply. So when I cross multiply, I get 1 times D, which is just D, and on the right hand side I will get 13 times the tangent of that value, tangent of 55, tangent of 55.58 degrees. So guys, to figure this out, we have to type it in the calculator. Keep in mind, sometimes calculator is in the radian mode. So guys, we are dealing with degrees here. So you got to make sure that the mode for your calculator is in degrees, okay? Make sure you make that change before you start multiplying or doing any math on here. So it is equivalent to, it's equivalent to 19. That is the length of the third side. So we have all the three things that we needed to figure out. Guys, here, this is of course one of the ways to finding the D. If I had used this equation, I would still get the same value. And then there's one more way, which you guys already know. I'm just going to remind you here, but let me get rid of this so that I can show you, or just going to remind you how to figure out the D. There's another way. Guys, this is a right triangle, and in the right triangle, you can, two of the sides are already known. To find the third missing side, you already know that one can use the Pythagorean, the nice Pythagorean theorem. Okay, so to use the Pythagorean theorem, we know D square is going to be 23 square minus 13 square, right? And then D square, you can simplify this, and I have already done it. It simplifies to 360. I use a calculator for that. And then finally, you have to take the square root to get the value for D. So when you take the square root of both sides, so you get D close to 19. And that is exactly what we got from using the tangent function, and that's what we would have got if we use the sine function. So there's always more than one ways, guys. There's few things that you have to keep in mind. One, always write that general form or like a shortcut way of remembering what is the sine, what is the cosine, what is the tangent in terms of the sides, ratios of the sides, and then from there you can set those equations, set those rules, and then figure out the missing pieces. Guys, this is equation example number 1. I'm going to show you many more examples in this section where we talk about how to solve a right triangle, and especially you can think of these as applications. Okay guys, till then, take care. I will see